So let's start. Today I will discuss a very important topic called ShopMill Programming. So before entering into the topic, we should know the M commands. M commands means miscellaneous commands. So M code means these are the codes to control the auxiliary functions in the CNC machines. For example, when we will give G00 or G01 to move the tool, right? So during the movement of the tool, we have to turn on the coolant, spindle rotation, tool change, right? So all these operations will be controlled by miscellaneous functions called M commands. So we have different functions such as M00. We will start with M00. M00 means programmed stop. So program will temporarily stop. So for example, you have a program N10 G1 X50 Y50 N20 M00, then N30 G1 X100 Y100. So this is the program. Imagine this is the program. Okay, so after executing, when executing this block, it will stop temporarily. So after that, the operator can check the workpiece or take the measurement, etc. Once it is completed, press NC start to continue the operation. So that is M00. Okay, so program will temporarily stop. Then we have another command called optional stop. Optional stop, the command is M01. Okay, so we have an optional stop key. We have an optional stop key on the machine. So we have to give M01 in our program and activate this key. If this key is on, then it will stop. Okay, if this key is off, then the program, even though this code is in your program, the program will continue. Even though the code is in your program, it will continue. So make sure that this one should be on. Optional stop key. Again, this is for inspection. Check the workpiece or take any measurement, etc. in between the operation. Then we have another code called M02. So M02 means program end. Okay, that means finished. So M30. So there is another code called M30. So I will explain what is this. What is the difference between these two? Okay, so if M30 is executing, it will reset the program. Okay, so again you can continue, reset the program. M30. M02 means program end, finished. Then we have two important code, M03 and M04. M03 means spindle will rotate in clockwise direction, and this is the most commonly used miscellaneous command. Okay, so for example, spindle speed is 2500 RPM and in clockwise rotation M03. So spindle will rotate in 2500 RPM. Then we have another code called M04. So M04 means spindle rotation counterclockwise. This is for special tools or left-hand cutters. Then to stop the spindle, we can use M05. M05 is to stop the spindle rotation. Then we have a code called M06. M06 means this is to change the tool. This is to change the tool. So using the automatic tool changer, tool will change. For example, T2 M06, that means tool will change. So tool number 2 will load into the spindle. So T2 M06 means tool number 2 will load into the spindle. Then M07 minimal lubrication on. That means this will activate the minimum quantity lubrication, MQL, minimal lubrication on. Then we have miscellaneous function related to coolant. M08 will activate, turn on the coolant pump. So this will be using during the cutting to cool the tool, right? And also to remove the chip formed. Okay, if coolant is using, it will remove the heat as well as the chips formed during the cutting operation. M09 means coolant off. Then M10. M10 means dividing attachment clamp on. M11 dividing attachment clamp off or loose. So rotary table or dividing hell will lock the clamp. Rotary table clamp will release if you activate M11. M17 means end subprogram. If you have a subprogram, it will execute, and after execution, it will go back to the main program, M17. M25 means open clamping device. Vice or clamping device will open. M26 means closed clamping device. M27 swivel dividing attachment. That means dividing attachment will rotate. M30 means program end. So what is the difference between M02 and M30 means? So M30 means, so you have a program consisting of say 4 blocks. Okay. So if this program end will be M30, okay. So once the program will completed, the cursor will go back to here. Cursor will be here. So in CNC milling program, this will be our last line, last command. Okay, N100 M30. So once this block is executed, the cursor will go to the starting beginning. So we can run the program again. Then M71 and M72 fan on. That means related to machine cooling fan and on and off. 71 is on, fan on, and 72 is fan off. So next we are going to create a ShopMill program. So I hope you understand what is ShopMill, right? Okay. So here we are not writing G code directly. We are not writing G code directly. And in the screen, we will give cycles. We will give cycles or parameters. Okay, using this to prepare the CNC program. And that type of graphical programming method is what is called a ShopMill. In other case, you will prepare the G code. In normally in CAM softwares, we will prepare the G code. Okay. So here the procedure will be like this. So the procedure will be like this. First of all, you have to open the program manager. So open the program manager. And then after that, go to new. And then after that, select ShopMill. And then after selecting the ShopMill, give a proper name. Give a proper name. If you gave a name previously, then if you click accept, it will not active. So you have to give a new name and click accept. Okay, give a new name and click accept. After that, uh, fill the program header. Then next is the program header. Okay, so I will write here what is program header. What is program header? So program header means these are some basic settings related to the full program. Okay, so for example, unit. Okay, normally we will use millimeter or we will use inch. Then zero shift, that means G54. That means the offset. Then clamping, where you clamped your workpiece on table or on a rotary axis. Then what is your raw part? Is it cuboid, cylinder, tube, polygon? That means the raw material shape. Then the raw part dimensions, x0, y0, x1, y1, height, width, length, etc. Once you set the program header, click accept. So at the same time, automatically create the header program and will be created in the block list. So what is the retraction plane or safety distance? Suppose, so listen, I will show here. Yeah, we have a picture here. Yeah, here you can see retraction plane or safety distance means so tool will safely move to a certain distance and it will be a rapid movement. Okay, so this value will be absolute value. So for example, this is our workpiece, right? So this is our workpiece, right? Okay. So this is the tool and this is our workpiece. Okay. And safety distance SC or retraction plane. And this value is absolute value. This is a safe distance to avoid collision before starting the cycle. This is a small safety distance. Okay. So for example, like this. Okay. So there will be a tool changing point where tool will change and select the correct tool. Okay. After tool changing, the tool will come rapidly to the retraction plane. Tool will come here. Okay. Retraction plane. Then there will be a safety distance, right? Okay. Then from there feed will start, and then after that it will enter into the workpiece and machining will happen. Okay, so this safety distance is a distance to avoid collision. So the processing direction, in the processing direction, we have a processing direction, right? So in the processing direction, we can select the milling direction, either downcut milling or upcut milling. Then next is the retraction position template. So based on the tool, if this is optimized based on the tool contour, will move through the safety distance. So time will reduce. So on RP, after every operation, the tool will move to the tool retraction plane. This is to avoid collision. So end of program, that means at the end of the program, tell the machine that, okay, machining is completed. If you give repetition, that means program will repeat. If you give repetition no, then the program will run only one time. So remember this repetition. If you give repetition yes, then the program will repeat again and again. If you give no, program will execute one time only. So this is what I told repetition. If you give yes, then the program execution will be repeated. No, the program execution will not be repeated. So safety distance, I have already told you, this is a safe distance from the top of the workpiece, right? So for example, this is the workpiece top. Say if this is Z0, then the safe distance will be say 2 mm. This is what is called a safety distance. So before starting the tool cycle, tool will come here, reach first. After that, feed will start. So retraction plane, this is used in tool rapid movement. Again, this is a safe distance. Okay. So once again, just imagine, I will explain. Yeah. So this is our, sorry, this is our workpiece. So this is our workpiece, and this is Z0, and this is what is called a safety distance, safe distance, and we have a plane called a retraction plane. Say retraction plane will be say 50 mm. Okay, and this safe distance will be 2 mm. So here, for example, if our tool is here, right? After tool changing, our tool is here. So first tool will come here on this plane, retraction plane. Okay, and then from retraction plane to here, again go rapidly. Okay, SC. Then after that, from here it will go slowly. Till here, it will be rapid traverse. From here, feed cutting. That means slow cutting. So next is what is called a program header. So program header. So program header means before starting the program, we should give some basic informations such as what will be the unit. So which offset you are using, is it G54, 55, 56? Clamping method, what is the shape of your raw material? What is the dimension of your raw material? If you give all those, then only shop will work. So first of all, you have to give the what is your unit? Okay, is it millimeter or is it inch? Okay, what will be the measurement unit? Then after that, 0 point shift. 0 point shift means where is your workpiece zero? That means you should mention your G54 or 55, 56, 57. Where you set your zero. Then clamping. How you clamp your workpiece? You have two options. One is you can directly clamp your workpiece into the machine table like this, or you can clamp your workpiece on a rotary axis. That means this will be in a fourth axis machining. Then what is your raw part? What is the shape of your raw part? Is it a rectangular block or a cuboid or tube, right? Cylinder, polygon like hexagon, octagon, triangle, etc. Then after that, you have to give the parameter x0, y0. X0, y0 means corner point in xy. So for example, you have a block like this. Let's take one example. So one corner point will be x0, y0. Then the next corner will be x1, y1. So that means 160. Thus that represents the size. That represents the size of your raw material. Then we have HA. So HA means this is the start height. So for example, HA. So for example, this will be your HA. So HA is equal to 0. Then you have HI. HI means N height. So N height means will be the thickness of your workpiece. So this is HI. So HI is equal to 20 means your material thickness will be 20 millimeter. Then you have XA. This is for tube or cylinder. What will be the external diameter? Then XI, again this is for tube. Again XI means internal diameter. N means polygon, number of edges. For example, you will be using hexagon. So number of edges will be 6. Then L represents the polygon side length. Say L is equal to 25 millimeter. W means width of the raw part. And L means length of raw part. So just imagine you have an aluminum plate. Just imagine you have an aluminum plate. Just imagine you have an aluminum plate of size 120 by 80 by 20. Okay. So first you have to give the unit, say in millimeter. Then after that you have to set what is your offset. Say it is G54. Then clamping will be on table, right? Then what is the shape of your raw part? It's a cuboid, right? Then what is the value of x0? Normally x0 is equal to 0, y0 is equal to 0. Then after that, x1 is equal to 120, so y1 is equal to 80, right? So then HA is equal to 0 and HI is equal to 20. That means it will be 20 mm thickness. Okay. Again, if you are using cylinder, okay, if you are using cylinder, then again the measurement unit will be in millimeter, and you have to select your raw part is cylinder, right? And then here you have to mention your XA. So what is XA? XA means diameter. What is the diameter? 80 mm. Then there is starting measurement. It is 0, right? And HI means 40. That means that represents the thickness of your. So like this. Thickness means the height, right? Then we can take another example called a tube. Okay. So tube means you have outer diameter, inner diameter, height, right? Again, you have to set your unit millimeter. Then here you have to select tube. Okay. And then you have to select what is XA and XI, because this is a tube, right? What will be the external diameter and what will be the internal diameter? Then what is HA and HI? What is HA and HI? Another example, for example, your object is a hexagon. Okay, your object is a hexagon. Your raw part is a hexagon. Okay, so for in this case, N is equal to 6, right? And L is equal to 30. So next I'm going to explain row part definition and cycle overview. So what is row part definition? So in your ShopMill simulation or machining, uh, for example, if you are using this as your blank, okay, what is the size? What is the size of this raw part? Okay, you have to define it. So as per the manual, they are saying that. So as per the manual, they are saying that if you are using, say, G54, if you are using G54 offset, and also if you will be using transformation, you should define the raw part from the stop point A. That means that will be the stop point, reference stop point. So M represents the machine 0 point, right? W represents the workpiece 0 point, and A represents the stop point or a reference stop point. So what is M? M means this is the machine 0 point. This is fixed, right? W represents the real workpiece 0 point. A means program or transformation will start from this reference point. Then let's see the cycle overview. When you write program in ShopMill, here we are not writing G code directly. Here we will be using cycles only. Cycles. Here you are not writing G codes, G00, G01, G02. No, you are not writing the G codes directly. Here you will be using cycles. So for example, we have different cycles. One is called a drilling cycle. So drilling cycle means this is for hole, right? This is for hole machine. Okay, so we will start with the centering. So centering means before starting the drilling, you have to mark the center. For that, we will use centering. Then drilling means this is a normal drilling process. To convert the drilled hole into proper size or finish, you will be using reaming operation. Okay, so if you drill your size of the hole is not correct. Okay, not proper size or proper finish. Maybe some small change will be there. So you, in order to convert your drilled hole to a proper size, you should do reaming operation. For long hole drilling or slot drilling, we have long hole drilling. So boring means you have a hole, right? In order to enlarge that hole or finish that hole, we can use boring operation. Thread means you can create a thread inside the hole, or we call it as tapping operation. Positions means we can define the hole positions. So these are the options related to the drilling cycle. Then we have a cycle called a milling cycle. So milling cycle means suppose you have a workpiece like this. Suppose you have a workpiece like this. Okay. So first one is face milling. Face milling means to remove the material from the top surface. Okay. So pocket means you can, for example, you have a shape like this. So you can create a pocket. In order to machine a pocket, we can use pocket milling. Spigot means if you have a raised boss like this. If you have a raised boss or a spigot, you can use spigot milling to machine that. If you have a slot, in order to cut a slot, we can use slot milling. Then thread milling means using milling tool, you create thread. And finally, engraving means you can write something. Okay, you can engrave letters A, B, C, D, or you can write numbers 1, 2, 3, 4, etc. Then we have contour milling. So, for example, this is your workpiece. Okay. So in contour milling, you can define a new contour. That means you can define a new contour, new profile. So path milling means once you prepare your contour, the tool will, if you use path milling, the tool will follow that contour. Pre-drilling. So pre-drilling means before doing the pocket milling or contour milling, we will do this drilling. So pocket means pocket machining based on a contour is what is called a pocket milling, pocket contour milling. Then in various represents different settings such as settings related to the cycle or program. Transformation means translation, rotation, coordinate transformation, etc. Subroutine means you can call a subprogram. If you want to repeat a program, then if you want to change the plane, swell plane, those options will be available in the various options. And finally, you have a simulation option to before actual cutting, before actual machining, we can check the simulation, the virtual movement of the tool related to the workpiece. Okay. Then straight line or circular processing. This is basic path programming tool, right? Then straight line, circle center point, circle radius, helix, all are machine functions. Okay, so first of all, you have to define your raw part correctly. Okay, if your raw part is correct, then you can check your simulation. Cycle overview means you can select the appropriate machining operations. Okay, so normally in lab, first we will start with face milling. Okay, then after that pocket milling, slot milling, etc. So next section will be define cycle and working with cycle. This is again a very important topic related to ShopMill program. So what is ShopMill cycle? What do you mean by ShopMill cycle? So cycle means this is a machining operation previously prepared. So normally what we will do, normally we will prepare G-code lines. Okay. So in order to avoid those situations, for example, we can select the appropriate cycle and then give the parameters only. For example, uh, for example, uh, just imagine you have a workpiece and you have a hole. You are going to drill a hole. Okay. So for that, you have to write n number of lines G code. But in ShopMill, what you can do is you have what to drill a hole. To drill a hole, you can select drilling cycle, right? So you can select drilling cycle, give the position of the hole depth, feed and accept. Okay. So if you give this, machine will automatically generate the G code. So that will be very easy. No need to write the code. No need to write the G code. Okay. So let's see, define a cycle. Now you are going to add a new machining operation. Okay. You have to select the cycle group. Okay. So which group? Okay. First you have to select the cycle group. You have different group, right? So drilling, then you have milling, then contour milling, etc. You have to select the group. And from the group, for example, you have milling, right? Then from that group, you have to select the proper cycle. Say, for example, from milling, you can select face milling, right? Then from face milling, you can select, say, um, pocket or slot or spigot, right? Then once you select that one, you have to give the required parameters. Parameters means what will be the length, width, depth, feed, tool, spindle speed, etc. Give the appropriate parameters. After that, press the accept. So if you press this accept, this will add to your program. This will add to your program. So in ShopMill, majority of the jobs related to cycles. So that means, so some jobs will be uh, done similar way, right? So all those machining operations previously prepared, face milling, pocket milling, drilling, slot milling, thread milling. Here, the thing is that you should give your appropriate parameters. No need to write the code. Once you give all the parameters, press the accept key, accept button, and then it will add to the, so that cycle will be added to your program. So once you added a cycle, you have edit functions, right? You have edit functions. Okay, using this edit function, you can copy, paste, you can paste or delete cycles. Then we have horizontal soft key extension. Okay, some options we cannot see on the screen. You can use this horizontal soft key extension button to check this. If you select the cycle, you should select the tool also. For example, say you will be using 10 end mill. So you will be using 10 end mill, or say 8 drill. So 8 drill. So what do you mean by geometry? Geometry data means this is related to the workpiece. Geometry data means this is related to the workpiece. For example, what will be the length, width, the depth, etc. So technology data means how you will cut this workpiece. What are the parameters? What are the parameters required to cut this workpiece? For example, what will be the spindle speed, say 2500 RPM? What will be the feed, 250 millimeter per minute, going on? So geometry represents the required length, width, and height of the workpiece, whereas technology data input means what are the parameters required to cut this workpiece. So we have collide positioning moments, right? This is very important. So in simulation, the tool movement will be in different colors. For example, we have red. Okay, so red represents rapid movement. Red represents rapid movement. That means there will be no cutting, but the tool will move very fastly. For example, G0, X100, Y50. So tool will be moving without any cutting, very fast movement. So green movement, then we have a green movement. So green represents tool will remove the material. That means feed movement. So for example, G1, Z minus Y5, F200. So G1, Z minus 5, F200. Then selection fields. So in some parameters, they have different options. So for example, measurement unit. Okay. Measurement unit is having millimeter as well as inch, right? Then processing direction, either downcut or upcut. So using your cursor, you can select the proper field. Using the select button, you can change the option. So next is cycle default values. Suppose when you will be using ShopMill and you will be using different cycles such as pocket drilling, face milling, etc. You will be using parameters, right? Depth of feed, safety distance, etc. If you want to use that again, you can control that using EMConfig software. EMConfig mean this is a configuration. This is a utility software to change the configuration settings from WinNC. So open the EMConfig software. Then after that, select the default values for cycle parameters. There you can see three options. One is always maintain, replace for restart, and never maintain. Always maintain means if you give a particular value to a particular cycle, so the controller will remember that value, even though if you restart the control. For example, we have a pocket cycle. If you gave depth 10 millimeter, feed to 50 millimeter per minute. If you turn off the machine and if you turn on it, so if you open the pocket cycle, the depth will be 10 mm and feed will be 250 millimeter per minute. So this will be very much useful in a production environment. Replace for restart means this will store till we restart the machine. If you, for example, if the pocket cycle depth is 8, during the operation, the depth will be 8. And if you restart the machine, the depth value will change. It will take a default value. Never maintain means if you close the cycle, all values will be converted into default values. For example, if the depth will be 12, feed will be 300. If you close the cycle and if you open the pocket, the depth value and the feed value will be default value. So in training situation, this will be the good setting because each student will get new default values, right? Plausibility check. So plausibility check means if the machine is giving some values, we have to check whether that value is correct or not. This is a safety validation. For example, if the pocket depth is minus 100 millimeter and the material thickness is 20, machine will show an error because depth will be more, right? So depth is minus 100, right? But the material thickness is only 20 millimeter. Okay, machine will show error because depth is more. Here the thickness is only 20 millimeter, right? If you ignore plausibility check for saving. If you turn on this option, even though there is an error, the accept soft key will active. So you can save the cycle. Then we have a tool length wear. This is basically related to turning tools only. So tool wear compensation based on the diameter and length. So in milling machine, so this setting is valid for turning tools only, not for milling tools. Then system of measurement. So in CNC machining, what is the programming unit using? Okay, is it metric system or imperial system, millimeter, meter, inch, or feet? So we can change this using EMConfig software. So go open EMConfig software and go to system of measurement. And then after that, you can choose either metric or inch. Save settings and restart the controller. If you select metric mode, then all the values will be in millimeter. Millimeter, that means X, Y, Z distance will be millimeter, feed will be millimeter per minute, tool length will be millimeter, work offset will be millimeter. If you select inch mode, then distance will be in inch, or inch per feed will be in inch per minute, tool length will be in inch. Okay, so make sure that if you have a metric program, okay, and do not run that program in inch control. And same way, if you have an inch program, do not run that inch program in metric control. See, for example, just imagine you have a metric program, say X100, right? Okay, so X100 means what is the value? 100 millimeter, right? Okay, but if your machine is in inch mode, what will happen? Okay, in inch mode means 100 inch will be is equal to 2540 millimeter. So what will happen? So tool will collide. So machine will damage. So make sure that your settings is correct. Your settings is correct. So this is the unit conversion table. Okay. So this is metric, right? So 1 millimeter. So 1 millimeter is equal to 0.001 meter, right? So 1 meter is equal to 1000 millimeter, right? So 1 meter is equal to 1000 millimeter. And 1 inch is equal to 25.4 millimeter, right? So 1 inch is equal to 25.4 millimeter. 1 inch is equal to 25.4 millimeter. And 1 feet. So 1 feet is equal to 304.5 millimeter. So next we can see this program header. Okay. Suppose you have a one piece. So suppose you have a one piece. Suppose you have a workpiece, right? Suppose you have a workpiece of 100 by 100. Suppose you have a workpiece of Suppose you have a workpiece of 100 by 100 by 25. Okay. So check what is the dimension of this workpiece. This is 100 by 25. So you have a workpiece of 100 by 100 by 25, right? Okay. So next you go to Program Manager. Okay. So here you are going to I'm selecting the two options, ShopMill and ShopMill and GCO. So now I'm selecting ShopMill. Okay, so I'm selecting convert the file. So here I have told you first you have to set the unit. So or inch, you can select either millimeter or inch. Then you have to select which offset you are going to use. 54, 35, 56, which offset you are going to use. Okay. Say let's take G54. Then you have to select this one. Okay. Your blank block, or is it pipe, or is it cement, or is it corner, is it corner is the poly. So now this is a block, right? Okay. Next you have to define this x0 y0. So now what is x0 y0? X0 y0 means this is your x0 y0, right? This is your x0 y0. So this is your x0 y0, right? So this is your x0 y0. So I can say this is 0 0 and next is x1 y1. X1 y1 means this one that x1 y1 will give you the size of your workpiece. So we know that it's 100, 500, right? Okay. Then then we have HA and we have HI, right? I have mentioned what is HA and HI. HA means it is the start measurement, right? So HA start measurement. So we can give this as 0, and then this will be HI will be almost 25. Then you have, I told you have a reduction plane. So reduction plane, you can give say, okay. So first the retraction plane, then safe distance you can give us 1 mm or 2 mm. Say same distance I will give this as 2. And the retraction plane, say this as so say 25. See, let's see here. Yeah, this HA means this surface, right? So we can set this as 0. HI means the bottom of that. So HA and HI will give you what will be the thickness of the box, right? So HA, retraction plane. So what will be the retraction plane means? The tool will come here. Try to see this. First of all, see, imagine this is your workpiece, okay? So first tool will come rapidly here, right? Okay. So this is what is called a retraction plane. So the tool will come very fast, and then it will come to here. This is what is called a safe distance, SC. This red color indicates rapid movement, very fast movement. Green means faint movement. That means very slow movement. So the tool will come very rapidly. Retraction plane. Then after that, it will come here. Okay, so the tool will come here. Let's see. This is what is called a safe distance. SC means safe distance. Okay. So please take your SC means your safe distance. So SC means your safe distance. Okay, so this red color indicates. So this red color indicates. So here you can see that you can visit the point. First of all, you should understand some basics about this. So, okay, retraction plane, let's say retraction plane, I can keep this as set will be fine. Then the safe distance means from that one piece, it is at a distance of 2. This tool will come very fastly here, and then after that, it will reach us here very slowly. Okay. You have retraction position pattern, you have two options, RP and optimize. RP means you have the retraction plane. So after completing the machining operation, the tool will go here, retraction plane. Or optimized means, for example, in this case, after completing this tool will come here. Okay. Okay. No need to go here. Then from here to here. Then from here to here, right? So no need to go here retraction here. So the system will optimize it based on this. Okay. The system itself will take the appropriate action. That is what is called optimize. So I can give RP. So RP means after completing this will go here. Yeah, so because I gave this is the retraction plane, right? 25 mm is the 25 mm is the retraction plane. So after completing the machining operation, it will go to the retraction. Okay, so this is what is called the program header. So I have selected the unit as millimeter, then work offset as G54, or okay, I will select as G56, then block, so size is 100 by 100. Okay, HI is 0, HI is 25, and get accepted. So I have given the program header. So here, this is what I told you, program repetition. If you select repetition yes, then the program will continue. After completing this, it will continue again and again. So click no. So once again, program header. Yeah, program header, everything is correct. Yes. So this is the first step. So suppose, so next is we will start our first one, that is drilling. Okay. So this is our first cycle group, drilling cycle group. This is to make what? This is to make a hole, right? Drilling is used to make hole or finish hole, right? Or you can create thread. You can create thread inside hole. So we have different cycles such as centering, drilling, reaming, deep hole drilling, boring, thread, and positions. First, we will start with centering, right? What do you mean by centering? Centering means, okay, suppose you have a workpiece like this. Okay, you are going to make a hole. Okay, so before starting the drilling operation, you will use a center drill. Okay, and you will make a cone shaped hole. Okay, otherwise what will happen if you directly use the drilling tool, sometimes it will move away from that location. So to avoid those situation, we will be drill first with the help of center drill, so that if you drill with your center drill, it will accurately hold. Okay, so that our accuracy will be more. So for that we will use center drill, or we call it as a sport drill. So for example, you have, so once again, so let's take this plate. You have a plate. Okay, so you are going to make say 10 holes. Let's take 10 holes to drill. Okay, first you have to do the centering, make a cone shape, and then after that drilling. So for that, so once the centering is completed, the next one is called a drilling cycle. This is to make cylindrical hole. We can make bolt holes, screw holes, general drilling. So you have to give the parameters such as what will be the position of the hole, X, Y, hole depth, feed, retract plane, safety distance, etc. Once the drilling is completed, the next one is called a reaming operation. So reaming means suppose you drilled a hole, right? So you drilled a hole, right? Okay. So after drilling, the quality of your hole is not that good. Okay, maybe some small error will be there. So in order to make the hole proper dimensioned hole, in order to make sure that the diameter is correct, and in order to make sure that the surface finish of the hole will be perfect, we will use reaming operation. Okay, so means your drill hole will be it will be like a rough hole. Using the reamer, we will convert this rough hole into a smooth hole, right? Okay, and we will convert this hole into an accurate diameter hole, right? So let's take I will give you one example. If you drill this hole, your diameter will be say 9.8 mm only. Okay, but if you use a reamer of 10 millimeter, okay, your final hole will be what? Final hole will be 10 mm diameter. So this is why you will be using what? The reamer. Then we have deep hole drilling. So what do you mean by deep hole drilling? So deep hole drilling means, again, let's take the one workpiece like this. Okay, you have a hole like this. So deep hole. So see, drilling means the tool will go directly from the top to bottom directly. Okay, but in deep hole drilling means first the drill will go some particular distance. Okay, then it will retract. Okay, then chip will remove, right? Then drill again, then again retract. This process will repeat. So that means, so what is the difference between drilling and deep hole drilling? So deep hole drilling means the tool will go a particular distance, then it will retract, then again it will go, then retract, again it will go retract. Okay, so because of that, chip will go outside. If the drill will come backward, again the chip will go up. We can avoid drill breakage, and coolant will reach properly. So that is what is called a deep hole drilling. Okay, so the next is what is called a boring. So boring means, again, you have a hole. Okay, we can increase the existing hole diameter and we can increase the accuracy of the hole. We will be using boring. So creating a hole, you can use drill. So reaming to improve the surface finish and accuracy. In order to enlarge, in order to increase the diameter of the hole, you can use the boring operation. So drilling means a new hole will be created. So boring means you have an existing hole. Enlarging that existing hole is what is called a boring operation, right? So for example, say for example, first you will be using 18 mm diameter drill. Okay. Then after that you will use 20 mm diameter boring tool to enlarge this hole. Then next is what is called a thread. Threading means you have to create thread inside the hole. So that cycle is what is called a threading cycle. So for that, we will be using a tool called a tapping tool. Okay. So for example, M10 thread. For example, M10 thread. Okay. So first we will drill, then tap. So finally we will get the M10 thread. Then position means, then what is called a position? So position means, suppose you have a hole. Okay. So in this hole, you need 4 holes. Okay. Hole 1, the point will be x0, y0. Hole 2, x, say 100, y0, like that. Just imagine 4 different values. Okay. So if you use this positions, what will happen is, and in the drilling cycle, machine will drill all these 4 positions if you select this positions option. Okay. So let's say I will give you one example. You have an aluminum plate. So you have an aluminum plate like this. Okay. And the holes, you have a hole. Okay. And the hole will be 10. And depth will be 20 mm. Okay. First one is centering, right? So that means you will make a spot here. After that, drilling. Okay. So here the diameter of the hole is 10. So we can use 9.8 mm drill. You can use, because the hole diameter is 10. So we will use 9.8 mm drill. Then after that, you can do reaming operation. So reaming, you can use the same diameter, 10 mm, right? So the threading, you can use M10 tap. Okay, so that's all about the overview of this drilling cycle. We will see one by one. Okay, we will see one by one. First, we will start with the centering cycle. Okay, so I have already mentioned centering. Centering means before doing the drilling operation, we will use a center drill or a spot drill. Okay, so the tool will be center drill or spot drill. Okay, and you will make a cone shape like this. Okay, so you will make a cone shaped hole using center drill or spot drill before doing the drilling operation is what is called a centering. Why we are doing this centering? If I am going to directly drill this hole, sometimes what will happen means sometimes the location will be changed. Okay, the hole will be in a different location. The hole accuracy will reduce. Tool wear will increase. Sometimes drill will walk away from this location. So in order to avoid all those situations, before doing the drilling operation, first we will start with centering. So this centering is very, very important in precision holes. Okay, so how you will do the centering? Okay, let's start the centering. First of all, you have to give the T. T means what is the name of the tool. Okay, T represents tool name. For example, T1. Okay, what is to T1? It's a 6 mm center drill. Okay, then after that, D represents the cutting number. Okay. This is to select the cutting edge. That means insert or blade. Okay. Normally in center drill, this will be D1. Then we have F. F represents feed. Okay. So feed will be in either millimeter per minute or millimeter per revolution. So for example, I have already discussed. Okay, let's take one example, 120 millimeter per minute. Give the feed. Then S/V represents the spindle speed. Okay, so spindle speed means revolutions per minute, RPM or meter per minute. Okay, spindle speed or constant cutting speed. So for example, 2500 RPM. So V represents constant cutting speed in meter per minute. Then we have centering. So in centering cycle, we have two methods. Option one is diameter. Okay. For example, if the center diameter is equal to 4 mm, then the machine center will drill till the diameter reaches 4 mm. So the center drill angle will consider the angle mentioned in the tool list. That is one option. And the second option is tips. So tips means depth. This is not based on the diameter. This will be based on the depth. For example, depth is equal to Z1 is equal to say minus 2 mm. That means the tool will go to till minus 2 mm. Okay. Then we have then we have Z1 drill depth. What is called Z1? Z1 means drill depth. That means this will be the final depth till the center drill reaches. That means say, so for example, 1.5. That means the center drill will reach here from the top surface till here, 1.5, say 1.5. Then DT means dwell time. So dwell time means, okay, dwell time means that the center drill will come here, okay, reaches here, reaches the bottom, okay. And if I give 1 second, so if I give 1 second, then the tool will stay here 1 second. You can give in seconds or in revolution, okay. If you give this dwell time in 1 second, so that means the tool will be here till 1 seconds. So how this cycle is working? Okay. So here we have 3 steps. Okay, so I will mention the 3 steps. The 3 steps mentioned here. Okay, so we have 3 steps. So step number 1 is machine will move the tool rapid traverse till say I have mentioned we have a retraction plane, right? We have a retraction plane and we have a safety distance, right? So machine will bring the tool rapidly. Rapidly means G0. Rapidly to the safe distance. Okay, that is step number 1. Then from here we have feed. Okay, I have mentioned what is the feed, right? That means slow movement. Then using this feed, the tool will enter into the workpiece. Okay, and you know what is Z1? That means depth. We already gave the depth, right? Okay, or the diameter, right? Okay, once the tool reaches here, it will stay say 2 seconds because the dwell time I gave us 2 seconds. Okay, once the dwell time is completed, okay, it will the tool will go back to the retraction plane. Okay, So this is what is the working of centering. So let's see our centering, right? Okay. Yeah. So now you are going to okay, listen. So program header you gave, right? So now we are using this, right? So what is the size? 100 by 100, right? And HA means this one, top one is 0, and HI means this bottom surface. So this distance is 25, right? And I have explained what is retraction plane safety distance, right? So retraction plane means, so tool will be here. It will come to the retraction plane very fastly, rapidly, a very rapid movement. That's why the red color. Red color means a very rapid movement, and it will reach us to the safe distance, rapid movement. Then from the safe distance, the tool will enter into the workpiece. Okay, clear? Yeah. Then you are going to select drill. Okay, so here, first we will start with the centering. If you are going to make a hole inside the workpiece, the first step is to do the centering, right? So okay, so here first you have to select the tool, right? Okay, so here you can see they used here you have to use a tool, okay, say 6.8 diameter, right? Then uh, this is B1. Then we have to enter the feed. What is the spindle diameter? Then if you gave it, okay, so what will be the Z1? Z1 will be 1.5 absolute. So 12 times say 1 second, right? So 12 times 2 seconds. Okay. So centering. Okay. So go to simulation. So that's all about centering. So next is what is called a drilling cycle. So what is drilling cycle? So drilling cycle means suppose you have a workpiece like this, right? So now you are going to make a hole uh, in a certain depth, right? For that you need drilling cycle. So if you select drilling cycle in ShopMill, machine will position the tool, give the feed to the drill, and the tool will move till the drill depth. If there is a dwell time, it will wait there and finally safely retract to the retraction plane. There is no need to separately write the G codes. So we will see the parameters again. Same. First of all, you should you know you should write the tool number, right? Say for example, tool number 2. What is tool number 2? 5, 10 drill. Then D represents the cutting edge number of the tool. Normally drill we will use D1. Then F means feed rate. Feed rate means how much speed the drill will go down. Okay, this is in millimeter per minute or millimeter per revolution. So for example, say 180 millimeter per minute. Then S/V represents spindle speed. Say for example 1800 RPM, or V represents the constant cutting speed. Then we have drill depth. So we have one option called shaft. So that means drill shaft reference. So this drill shaft will go to that specified position. So here the Z1 will be based on the drill shaft. Then the second one will be based on the tip. Okay. So you have two options. One is shaft reference and the second one is tip reference. So the machine drill will go to till Z1. So normally we will use this option, tip option. Okay. And then Z1 represents the drill depth, say for example, minus 20 millimeter. So machine will, that means this distance will be 20. So machine will drill this hole 20 mm depth, and DT represents the dwell time. Again, say 1 second, 2 second. So if the tool reaches here, it will wait here 1 second time or 2 seconds time. After that, the tool will retract to the retraction plane. So the cycle will work like this. Again, similar to the previous one, 3 steps. I will explain the 3 steps here. Okay. So step 1 will be we have the retraction plane and safe distance, right? So tool will be here, retraction plane, safe distance, right? And the speed will be rapid traverse. Okay. So from here, the tool will move using the machine feed rate. So it will drill this hole till Z1. Okay. And if we have a dwell time, waiting time, the tool will be here for some time. And then after that, it will go back to the retraction plane. So you can see if there is a tool change position, from the tool change position rapidly, the tool will be here, retraction plane, then safety distance, then feed, it will go to till Z1. And then if there is a dwell time, the tool will wait there. And then again, it will go back to the safe distance retraction plane. This is the procedure. Okay, so we will see this on the machine. Let's see drilling operation. So let's select drill. So centering is completed. So the next step is drilling. Select drilling. So you have to select the appropriate tool. So we say I am entering 120. Then so you have two options. One is shank and another one is tip. Okay. So normally we will use tip. So how much distance the tool will go into the workpiece. So this much distance. Okay. Say 20. Okay. So I will change this to 20. Okay. And the tool will be there 1 second time. Okay. And click accept. Okay. After centering, drilling will be happening. Okay. Now next is so now the next step is reaming operation. Now the next step is the reaming operation. Okay, so now you have a hole drilled, right? So the next step is to the next step is to convert this hole into an accurate hole with good surface finish. So this is what is called a finishing operation. We can call it as a finishing operation. So again, same procedure. We have parameters such as T. This is the name of the reamer tool. And then D represents the cutting number. F will give you the feed. Then FR means feed during the retraction. Retraction means if once the reaming operation is completed, the tool will be retracting, right? So what will be the feed during that retraction? That is called a retraction feed. Then S/V, spindle speed or constant cutting speed. Z1 will be the depth, this reaming depth, and DT represents the bottom dwell time. So again, the procedure will be same as I have already mentioned. We have the retraction plane. We have a safe distance, right? So tool will be come here. So using, G0, right? Rapid traverse. Then it will, yeah. So the tool will be here. Then from here, it will reaches the safety distance and the speed will be rapid traverse. Then we have given the feed. So using this feed, the tool will be go here till Z1. If there is a dwell time, the tool will be here, say 1 second time. After that, retracted back to the retraction plane. So during the retraction, this is very important. Okay. So do not give any rapid movement. Okay, give a controlled feed. Okay. Otherwise, it will affect the quality of the whole surface. So give a controlled feed so that it will directly go back safely retracted, so that we will get a proper surface finish for it. So let's try this in the machine. Next, select the reaming operation. So go to the reaming option. Okay. Then you have feed speed, everything. അല്ല ഓക്കെ ഉണ്ട് സാർ ഇത് വന്നു കഴിഞ്ഞാൽ ഇത്രയും മികച്ച PhD പഠിക്കാൻ സെറ്റപ്പ് പ്രിപ്പയർ ചെയ്യാൻ ഇത് വന്നല്ലോ So the next section is deep hole drilling. So deep hole drilling means if the depth is more, then we will use deep hole drilling. Okay. So deep hole drilling means the drill will. So this is the full depth, right? So normally what drill will do? The drill will go directly from here, then it will reach us here, then retracted back to the retraction plane, right? But in deep hole drilling, first the drill will come here, right? Okay. Then it will retracted back. Okay. Then it will go, then retracted back like that. This is what is called a deep hole drilling. So this is having two different methods. One is chip clearing and chip crushing. So chip clearing means chips will completely out. So drill will come out of the workpiece and chips will be completely out of the workpiece. Chip crushing means drill will go a certain distance and the chip will be crushed. That is what is called a chip crushing. There are two methods, chip clearing and chip crushing. So what are the different parameters? Similar to the previous one, first of all, you have to mention the drill tool name, and D represents the cutting number. Normally we will use D1. F will be the drilling feed. S/V represents spindle speed and constant cutting speed. Then Z1 represents the final drilling depth. Okay, this represents the final. This will be the final drilling depth, Z1. And D means maximum depth per infeed. And FD1 first infeed feed percentage. So DF means percentage rate for each additional infeed. So V1 means minimum depth infeed. V2 means chip crushing. V2 V1 will be the minimum infeed depth. V2 will be the retract amount during the chip crushing. V3 means advanced stop distance during the chip clearing. And DT represents the bottom dwell time. So let's see this one. Okay. So I have mentioned chip crushing and chip clearing, right? So we have the retraction plane, we have the safety distance, right? So tool will come safety distance rapidly. Then the infeed depth, drill, okay. Then it will retract at V2 amount, okay. Then it will drill the next depth. This will continue till the Z1. Finally, if there is a dwell time, it will wait there and tool will come here and retract it back to the position. Then chip clearing. So chip clearing means so it will drill infeed depth. Okay. Then after that, to clear the chip, tool will move from the workpiece to the safety distance. Okay. Then go again with the V3 advanced stop distance. This will go rapidly. Then it will drill next infeed depth and this process will continue. Say, let's say one example. Now you are going to drill using 8 mm drill. Okay, deep hole drilling, and the depth of this hole is say 50 mm. So the feed is say 120 mm per minute I'm giving, and spindle speed is say 1800 rpm. So the depth is so Z1 is 50, right? So maximum infeed is say 5 mm. FD1 is say 70 percentage. V2 1 mm, and dwell time say 1 second. Okay, so let's see this in our machine. So go to Program Manager, open. So select the drill. So that's it. So default drill, select the default drill. So give the feed, spindle speed, then we have chip breaking or chip removal. So chip removal means so tool initially tool will be here, and it will come here, then reflected back, then it will go here, then it go to the distance, then go back. So this is chip breaking means initially tool will be here at a safe distance, and it will come here, retracted. Okay, then it will go to the depth, retracted. Okay, so I'm using chip removal. So Z1 means say 25. Okay, I'm using 25 absolute. Then this is the Z1 means this is the depth, right? So this is tip. Okay, Z1 means this is the tip, right? Okay, then Z1. Okay, then D means this is say 5, and percentage say 70 percentage, 70 percentage. Then we So next is boring cycle. Okay, suppose boring cycle means you have a hole, right? So you have a hole here. Once the drilling is completed, boring is the process to convert the hole into required size using boring tool. And using the boring tool, we will machine inside this hole. And also we can make the surface of the hole. We can finish the surface of this hole. This is like a finishing operation. So if you need an accurate hole, drilling plus boring, okay, this will give you an accurate hole. Again, what are the parameters? So T represents the tool name, that means the boring tool name. D is the cutting number. F will be the boring feed. S represents spindle speed. V means constant cutting speed. Z1 will be the boring depth. And DT means the bottom dwell time. SPOS means spindle stop angle position. Then lift to mode. Tool, uh, this is related to the retraction, whether the tool retracted from the tool hole edge. So D means the lift amount. So lift lift mode, right? So this lift mode means, suppose this is our hole, right? So this lift mode means is very useful. Otherwise, surface scratch will be happening. This is very much useful in high accuracy boring. So do not lift means tool will directly enter into the retraction plane rapid traversely, but the surface scratching, the possibility of surface scratching will be more. So in that case, we will be using lift mode. Okay, so again, you have the retraction plane, then you have the safety distance. So tool will come here, safety distance. Then using the program to feed, this will go to the Z1 depth, right? Then if you have a dwell time, it will be here. As per the SPOS, the spindle will rotate. Then if the lift mode is on, a certain lift amount, it will retract and it will go back to the safe distance or retraction plane. This is what is called what will be happening in boring. So for example, let's take so we have a tool, boring tool, say T5. Let's take T5 will be the tool. Then the boring feed will be say 60 millimeter per minute, and a spindle speed, say I will give say 700 RPM. Then dwell time I will give us 1 second time. Then SPOS means say 0 degree. Then lift mode means lift, and the lift amount will be say 0.5 millimeter. So this much amount retracted and then go back to the retraction plane. So let's see this in the machine. Go to boring operation, select the tool. Okay, give the feed, give the spindle speed. Then Z1 will be the boring depth, and the PT means dwell time, SP1. Then left mode means And then coming through the next one, that is the tapping. So tapping means you have a drilled hole, right? So inside this drilled hole, you are going to create what? Internal thread. You are going to create internal thread inside this drilled hole. This operation is what is called tapping operation. First, drill the hole using the drill tool, and then after that, using the tap tool, create the thread. So the procedure will be like this. Okay, first centering, right, then drilling, then after that tapping, like this. This is the procedure. So tapping will be, say, then the thread will be, say, M6 thread, M8 thread, M10 thread, like that. Okay, let's see the parameters. First of all, T. T represents the tapping tool name. D means the cutting number. Then table means you have to select the standard. That means select the thread standard. Then selection which one? M6, for example, which one? M6, M8, you have to select the thread. Then P represents the thread pitch. Then S/V, again spindle speed and constant cutting speed. SR, so SRVR means this is the uh, spindle speed as well as cutting speed during the retraction. And then Z1 Z1 will be the thread depth or thread endpoint. D means the maximum depth in feed, and V2 means this is the retract amount during the chip crushing. So from the thread table, you have to select the standard. So if you select none, that means you have to give the pitch manually. Okay, or you can choose isometric, then Whitworth BSW, then Whitworth BSP, then UNC. Okay, for example, from the table you can select isometric and M8. Okay, if you use M8, okay, then it will use the standard pitch automatically. So pitch means the revolution, one revolution of the thread, how much distance the tool will move. Okay, so for example, if thread is M8 into 1.25, that means this 1.25 will be the pitch. That means this much distance. Okay, this much distance tool will move in one revolution of the in one revolution. Okay, so tool 1.25 mm distance in one revolution. So here we have compensating chuck mode. So compensating chuck hold means in the tap holder, it is having a small axial compensation. If there is a small feed mismatch, that will absorb. So without compensating chuck means accurate machine feed, spindle feed synchronization required. So the processing type will be three types. One is the processing type will be three types: one cut, then chip crushing, and chip clearing. So one cut means, okay. So for example, this is the hole. Okay, so it will go till here, Z1, uninterrupted. The next is chip crushing. Chip crushing means chip crushing means uh, first a small depth tap will be created, then after that small retracted, then break the chip using V2 retract amount. Chip clearing means uh, tap will completely out of the workpiece, clear the chips using deep threads. That is the three different types of processing: one cut, chip crushing, and chip clearing. So the processing will be like this. Again, so we have our safety distance, right? So we have our safety distance and we have the retraction plane, right? So tool will come like this. Okay. Then the tap will go into this hole using the spindle rotation with the feed till the tap will reach us here. Is that one, right? Okay. So based on the processing, one cut, chip crushing, or chip clearing, based on the type of the processing. Once this will reaches the thread depth, spindle will reverse, and tap will be come outside and go back to the retraction plane. So once this tapping is completed, the spindle will reverse. Okay, spindle will reverse and go back to the retraction plane. So let's see one example, right? Okay, so for example, now you are going to make an M8 thread. Okay, now you are going to make an M8 thread. Okay, now you are going to make an M8 thread, right? So the tool name is what? Tool name is T6 M8 tap. Okay, and the cutting number, then table. I am selecting isometric, right? Isometric, and selection I am selecting M8, and the pitch I am giving as say 1.25 mm per revolution. Then S means RPM, spindle RPM, say 500 RPM. Then SR during the retraction, again it will be 500. Z1 will be 15. And processing, I am using one cut. If you select a wrong pitch or using a wrong thread table, then your tap will break and your thread will become damaged. So tapping pitch, spindle speed, feed synchronization, everything should be correct. Everything should be correct. Okay. So right now I'm going to select threading option. Okay, so tap M8 I'm selecting. So from the table you have to select. If you select none, you have to give the pitch. Or if you select isometric, you will automatically select the pitch 1.250 mm per revolution. Then S means say what is this speed? Say 600 RPM. So this also 600 during the retraction. So S means this is the spindle speed. SR means this is the speed during the retraction. One cut means it will go directly and go back. So Z1 means how much? Z1 means say 15. 15 will be the thread depth. Okay, so this is what is called a thread table. So this is what is called a thread table. Okay, so in the thread table, where you can see the commonly used thread sizes and their pitch. So here you can see the commonly using thread size and pitch. So for example, let's see some examples. Okay, so let's see some examples. Isometric. So for example, M6. Okay, say M8, M10, M12. See what is the pitch? M6, 1 mm per revolution, right? M8, 1.250 mm per revolution. M10, 1.5 mm per revolution. M12, 1.750 mm per revolution. So in the thread table, you can see commonly using thread sizes and their pitch. So if you use M8, make sure that your pitch will be 1.25. Then coming to UNC. So this is using, inch thread systems. So for example, 1/4 inch 20 UNC. So threads, this is threads per inch. Okay, this is threads per inch TPA. That means 20 TPA. Then 3/8 inch 16 UNC. 16 TPA. 16 TPA means threads per inch. Then 1/2 inch 13 UNC. 13 TPA. Okay, next is thread tapping with the compensating check. So if compensating check will be there, tap holder will absorb small axial movement. So that means the tool will move rapid traverse, reaches the safety distance. Then using the tool programmed spindle speed, it will travel to Z1 thread depth. Machine will control its feed and calculator. Once Z1 reaches, spindle will stop, then it will rotate in reverse direction, and then finally it will reaches to the safe distance. Then it will go to the tool retraction plane. Without compensating check. One cut. Here spindle feed synchronization should be more accurate. So tool will come to the safety distance, then spindle synchronize, start with the S speed, tap will reaches Z1 depth and cut the thread. Once it will reaches the Z1, spindle will stop and reverse. Using the SR return speed, it will come out of the hole. Then spindle will stop and it will go back to the tool retraction plane. Then chip clearing means here deep thread will be using. So tap a certain depth will thread, then spindle will stop, then tap will come out of the workpiece, chip will clear, then again next depth will thread the next depth, and it will continue till Z1. Then chip crushing means tap will go to the first infield depth, then spindle will stop, then after that using the V2 retract amount, it will come out, then it will go another depth. It will continue till where? It will continue till Z1 depth. So when we compare this chip clearing and chip crushing, so in chip clearing, tool will be completely out. Okay, but in chip crushing, a certain amount only retracted, V2 amount. In chip clearing, chips will be completely clear. But in chip crushing, chips will break. Chip clearing will take too much time because the tool will be completely out of the hole, right? Chip crushing time will be less. For deep thread, chip clearing will be good. For medium depth, chip crushing will be good. So next section is mill drill thread. Okay. So here, here we will drill one hole, right? Okay, and then using thread milling, create an internal thread. This is a combined cycle actually. This is a combined cycle. First create a hole, then after that, create an internal thread. That means we can do two operations, drilling plus thread milling. So in tapping, we will use tap tool, right? But in thread milling, we will use thread mill cutter to create circular or helical path. What are the parameters? The parameters used are T represents the tool name, D will be the cutting number, F will be the drilling feed, S means spindle speed, V means cutting speed, Z1 will be the thread length. So what will be the length of this thread length or thread endpoint? DF means how much in-feed depth, DF. Then V1 means minimum in-feed depth. And F2 means thread milling feed, right? So From the table, you have to select the standard, whether it will be ISO, Whitworth, UNC, etc. Then selection, you have to select the thread, say for example, M8. P represents the pitch. Z2 means retraction amount before starting the thread milling. 5 represents the nominal thread diameter. So this DF means how much additional feed is required. For example, last in feed will be 5 mm. So DF will be 80%. So the next in feed will be 4 mm and the next will be 3.2 mm. This will reduce the tool load. Then boring with reduced feed. If you select yes, your whole quality will improve. It will reduce the feed during the boring or feed finishing. Through drilling, if you select hole through drilling, you can use S, where ZR represents the remaining drill depth and FR means remaining depth drill feed. Chip clearing, if you select chip clearing yes, then it will go back to the tool surface. This is for deep hole drilling. And the thread direction will be either right hand or left hand. Normally, we will use right hand thread. From the thread table, we can select the appropriate thread. For example, isometric M8. So M8 means pitch will be 1.25 mm per revolution. M10 means pitch will be 1.5 mm per revolution. So let's see this in the machine. So this one is very important, position and position template. This is one of the main concept in ShopMill programming. Means in machining cycle, for example, drilling, centering, tapping, you will be doing same operations, different locations. So position template means, for example, let's say, uh, for example, let's say this example, you have, let's say you have a workpiece. So let's say you have a workpiece and you have holes of different diameters. Okay, so that means you have 4 holes, right? 1, 2, 3, 4, right? So in this case, no need to write drilling cycle for these 4 separate holes. Okay, so just write one drilling cycle program only. Just write one drilling cycle program. After that, you can select the template. Okay, you should give us position template. All the whole locations, you should give us position template. Position template. So in that case, machine will drill all those positions. So let's take another example. So let's take one example. You have a plate, okay, and that plate contains say 16 holes. 16 holes. If there is no position template, what will be the procedure? First, take the center drill, then drill hole number 1, then again take the center drill hole number 2, center drill. Okay, so in that case, your program, the length of your program will be huge, right? But if you use a position template, okay, if you will be using a position template, first you will give center drill, then after that drilling cycle, center drill cycle, then drilling cycle. After that, position template. Then it will machine all the 16 holes, right? So once again, you have center drilling cycle, then drilling cycle. After that, you have position template. You have position template, right? So based on the position template mentioned, we have 5. So first one is arbitrary positions. That means you can give your own coordinates. For example, x1 will be x20, y20, then hole number 2, x60, y30, hole number 3, x100, y40. Random positions you can give. And the next one will be a line pattern. Line pattern means you have a straight line and this straight line contains holes. That is called a line pattern. Okay. Or you can use a grid pattern. So grid pattern means like a, like a matrix. Like a matrix. So for example, you have a 3x3 hole, or you have a 4x4 hole, like this. 1, 2, 3, 1, 2, 3, 1, 2, 3. This is what is called a grid pattern. And another one is called a frame pattern. So frame means you have holes near to the border. Okay, you have holes near to the border. Then the next one is positioning on full circle or partial circle. Okay, so for example, you have full circle or half circle. So in a program, you can use different templates, such as, for example, in a program, you can use say grid template, right? You can use circle template. You can use arbitrary random template. So this type of template, so many templates you can use. So for example, you have say you have program header, end of program, after that drilling, then after that you can give the positions. Then we have repeat position. There is another option called a repeat position. Okay, you have one position template, right? Okay, no need to program again. Simply repeat position and then give the position number. Then machine will go and machine all those locations. Okay, next we will see more details about arbitrary positions. In drilling, centering, reaming, tapping, those type of operations, we can use this. So what do you mean by arbitrary position? Arbitrary position means you have to give the XY coordinate to the, say, suppose you have three holes. So you have to give what is the X coordinate and Y coordinate of this hole, this one, and this one. Okay. So for example, you have hole number one, say what is XY, two, what is the X and Y. This will not be like a line or a grid. So random, you have random positions. You can select, you have two options. You have two options. One is orthogonal and polar. Orthogonal means you have to give X and Y value. If you select, if you select polar coordinates, then if you select polar coordinates, you should give length, radius or distance or and an angle, right? Then you have, line, grid, or frame. So line means all will be in a straight line, right? Then grid means if you have rows and columns like this, if you have rows and columns, you can use the grid pattern. So frame position template means you have a rectangle and the holes will be on the border. You can use this frame position template. If your hole positions in a regular pattern, you should use line, grid, or frame. If it will be a random position, you can use arbitrary positions. Before running the program, check the simulation. First, you check the simulation and after that, run it. Okay, then next one is the circle position template. So you have a workpiece and the hole will be like, the circular hole will be like a circular shape, bolt circle or PCD. This will be, you can see this will be commonly in flanges, couplings, gears, motor mounting plates, bearing housing, etc. Okay, so the parameters will be like this: Z0, X0. Z0 means the reference point Z position. X0, Y0 will be the circle coordinates. Alpha 0 will be the start angle. Alpha 1 will be the angle between holes. R will be the circle radius and N will be the number of holes. Positioning straight or circular movement. Another one is called obstacle position template. Obstacle means, okay, suppose if the machine is moving, right, we should avoid something that is what is called obstacle, right? So, for example, clamp, vise, fixture, tool component, etc. So the parameter will be Z. Z will be the obstacle height. Okay, so that's all about related to the drilling cycle. So next session we will start our milling cycle. So you can choose this one, random, or you can choose line, looks like a straight line, or circular pattern line means you can choose grid. Okay, line you can choose grid, or frame you can choose right. Then arbitrary you can choose rectangular or polar. Then this one circular with circle, full circle, okay, obstacle. Okay, so obstacle, this will be the obstacle, right? So it will avoid this. When we come here, we should give the obstacle distance, right? So it will go here like that. That is what is called obstacle.